Good morning. Today we are talking about nomenclature ionic compounds. Ionic compounds contain metals and nonmetals, and if you recall, the metals are on the left side of the periodic table, and the nonmetals are on the right side of the periodic table. We can also say that ionic compounds contain cations and anions. Remember, cations are positive, anions are negative. The metal or the cation is always written first in an ionic compound. It's also interesting to note here that the only cations that are positive are ammonium and hydronium. Ammonium is NH4 with a +1 charge, and hydronium is H3O with a +1 charge. Those are the only two positive polyatomic ions. So when you're looking for an ionic compound, you will have a metal or ammonium or hydronium. No other choice. The metals become cations with a positive charge, and the nonmetals become anions with a negative charge. Metals also keep their original name, same as when they were an element. Nonmetals change their ending to "ide." If you've been learning your anions, then you know that the names of these are nitride, phosphide, oxide, sulfide, fluoride, chloride, bromide, and iodide. So they have the IDE ending. Most of the charges for the metal and nonmetal ions can be found by looking at your periodic table. If you haven't already done so, label your periodic table as follows: +1, +2, silver is +1, zinc, cadmium, mercury +2, aluminum +3, nitride, phosphide -3, oxide, sulfide -2, fluoride, chloride, bromide, iodide -1. Remember, the metals become positive and the nonmetals become negative. Remember, when naming ionic compounds, the metal's name remains the same as the name of the metal. The nonmetal's ending changes to "ide." The first thing we're going to do with our nomenclature exercise is to write formulas. When we're writing formulas for ionic compounds, the charges must balance. We will use subscripts for this purpose. Subscripts are the little numbers at the bottom that you see in formulas. If the ions are already balanced, there's no need for subscripts. You simply write the formula or symbol for the cation and anion with no additional subscripts. When I'm starting out with nomenclature, I always put the charges above the name. In that manner, I can see if they need to be balanced or not balanced. So sodium is +1, chloride is -1. How did I know that? I looked at my periodic table. +1, chloride, -1. Aluminum, +3, nitride, -3, again from the periodic table. So sodium is balanced with chloride. +1 - 1 = 0. I simply put the symbols sodium, Na, chloride, Cl. The formula is NaCl. Aluminum nitride, same thing. Aluminum +3, nitride -3. It's balanced. Al(N). Again, make sure you write your symbols properly, capital letter, lowercase, capital. Let's look at some more examples. What if charges do not balance? If charges do not balance, the easiest way to balance charges is by crisscrossing. However, you never write the subscript 1. Again, I'm going to put the charge above the name. Barium +2, phosphide -3. Your goal is to have the same positive charge as you do negative charge. We can do that easily with crisscrossing. That means bring the number for the positive down as a subscript on the negative. Bring the number for the negative as a subscript down for the positive. This allows us to say 3 times +2 equals +6, 2 times -3 equals -6, a +6 minus 6 is balanced. Barium, symbol Ba, subscript 3, P, subscript 2. Barium phosphide. Silver has a +1 charge, sulfide -2. How many silvers do we need to balance out with the sulfur or the sulfide? We need 2. Common sense tells us 2 times +1 is +2, -2 is 0. Again, if you don't realize that, then crisscross. But never write the subscript 1. So the formula is Ag2S, silver sulfide. We do write formulas close together. Remember, they are bonded. So when you're writing formulas, make sure that you put the symbols close together. This would be incorrect. They're too far apart. When writing formulas, subscripts must be in their simplest whole number ratio. The example stannic oxide, stannic, if you've learned your transition metal ions, is +4. Oxide is -2. The proper formula is SnO2 because we know that we need 2 oxides because 2 times -2 would be -4, which would balance out the +4. If you simply crisscrossed here, you would end up with Sn2O4. This is incorrect. If you get Sn2O4 by crisscrossing, then simply reduce, which would then give you SnO2. Never write charges in the final formula, nor do you use Roman numerals in any formulas. They are only used when naming transition metals in compounds. Transition metals are those elements in the middle of the periodic table that go over to the edge of the stair step. Here's our screenshot again of the periodic table. These are the transition metals. And we find out that these elements in this area over to the stair step may have varying charges, except for silver, aluminum, zinc, and cadmium. The rest can have different charges. The way we determine the charge of those transition elements is in finding the charge of the nonmetal or the anion portion. And you must know the anion before the charge of the metal can be determined. The name of the metal is determined by the charge of the metal. So let's look at 2 examples. You have CuO. We know that oxide has a -2 charge. Therefore, this copper must be +2 because we know this is -2, so this has to be +2 because there are no subscripts. So the name of this compound is copper 2 oxide or cupric oxide. In our next example, Cu2O, again, we know that oxide is -2. However, this time there are 2 copper ions. This would mean that each copper must be +1 because 2 times +1 is +2, -2 equals 0. If we wanted to do an algebraic expression, this is what it would look like. Let's do some examples. Aluminum sulfide. Aluminum +3, sulfide -2. The easiest way to balance is by crisscrossing. So the 3 comes down as a subscript, the 2 comes down, Al2S3. Double check, 2 times +3 is +6, 3 times -2 is -6. My suggestion while you're watching this is to stop the video at this point and practice some of these, then come back and see if you have them correct. Calcium +2, bromide -1. We need 2 bromides to balance out the +2 calcium, so CaBr2. Remember, regardless of how you're doing this, whether you call it crisscrossing or just making them balance, the goal is your positives have to equal your negatives. So we see we have to have 2 negative ones to balance out the +2. Magnesium +2, phosphide -3. Again, crisscross would probably be the easiest. Mg3P2. lead 4 oxide, lead 4, plus 4, oxide negative 2. Here is our example where we need to be careful and not crisscross when it's not needed. I need 2 oxides because 2 times negative 2 is negative 4. Symbol for lead is PbO2. Strontium plus 2, chloride negative 1, SrCl2. Titanium plus 2, chloride negative 1, TiCl2. Silver plus 1, iodide negative 1, AgI. Couple of questions students often ask is, in this case for iodide, why isn't it I2? I thought iodine was diatomic. Iodine, the element, when it is free, is diatomic, but it is not diatomic when it's in a compound. So here we are balancing charges, plus 1, negative 1, AgI. A couple other questions people have is, how do you know these charges? Go back to your periodic table. Alright, now on this side of the periodic table, this side of the worksheet, we're going to actually be writing names. The names are the name of the metal or the name of the anion, but if it is a transition metal, you have to decide the name based on the charge. Our first example is a transition metal ionic compound, and I label that as Ti. So I first look at my chloride charge, that's a negative 1. 2 times negative 1 equals a total of negative 2. What must lead's charge be? Since there's only one of them, it must be, of course, plus 2. So the name is lead 2 chloride, or I could call it plumbous chloride. Sr3N2. I do not have to determine the charge of Sr because I know strontium is always plus 2 and I don't name it with a charge. So I simply know the symbols. Strontium. Nitrogen is the anion here, so it's nitride. Strontium nitride. If you've learned your ions, this is not hard for you. FeO, transition metal ionic. How do I know that? It's on the periodic table, in the middle of the periodic table. Oxide, negative 2. What must iron's charge be? Plus 2. So the name is iron 2 oxide, or ferrous. Do I have to know those old names? Yes. Sn, in the middle of the periodic table, transition metal ionic again. Fluoride is negative 1. There are 4 fluorides, so that's a total of negative 4. This 10 must be plus 4. So the name is 10,4 fluoride, or stannic. 10,4 fluoride or stannic. Al2O3, those are not transition metals, they're simply aluminum oxide. KBr, potassium bromide. And the last example, Na2S, again, not a transition metal, simply sodium sulfide. Again, my suggestion after watching this is to have a blank one of these and do them on your own.